Part C was to evaluate the definite integral from 2 to 3 of 5x over x plus 3 dx. And so because the integrand of this integral is a quotient, and we don't know how to reverse the quotient rule, taking the antiderivative of something by reversing the quotient rule, we had to use u substitution. Or you could have divided 5x by x plus 3 and done it that way and to rewrite this integrand, but I did it with u substitution and made u x plus 3, so then I could plug in u for the denominator of the function and then rewrite x as u minus 3. So to redefine the bounds of the integral, I just plugged in 2 and 3 into the equation for u in terms of x and got 5 and 6. And then du over dx is 1 by the power rule. And so dx, therefore when you solve this, equals du. So I could just plug in du for dx. And so this was the integral in terms of u. And so I distributed the 5 to the u minus 3 to make it 5u minus 15, and then times u to the negative 1 du. And then I simplified that to 5, again with the distributive property, minus 15 over u du, integral from 5 to 6, which when you take the antiderivative of this integrand to solve it, using the power rule for this 5, it's going to be 5u, and then using the reverse of the logarithm rule for this 15 over u is going to be 15 natural log of absolute value of u, and then from 5 to 6. And so I plugged in 6 and then subtracted from that the value when 5 is plugged in of this expression and solved it down to 5 minus 15 times natural log of 6 over 5.